The complex ion formation, for complex ion formation, if you look up KEQ for these reactions, they're usually tabulated. You might find it tabulated as log of the KF instead of negative log KF. And the reason for that is KF typically is a large number. Okay, and so if you take the log of KF, you get like a whole number, positive whole number, so you don't need to put a negative in front of it. So instead of PKF, they're tabulated as log KF. So for example, the log KF for silver amine complex, okay, AgNH2 with a positive 1 charge. If you look it up, you'll find that to be 7.05. Okay. You can also look up what are known as stepwise formation constants for this complex ion. The first step is you just pick up one ammonia, okay, and you can look up the log for that to be 3.24, log of the equilibrium constant for that. And then if it picks up another ammonia molecule, so now you have AgNH2, okay, there's another formation constant for that. The question is, what's that number if the overall formation constant is 7.05? How can we calculate log K2? Well, let's look at these two reactions. What happens if you add these two reactions? Let's combine them. You have Ag plus, what happens to this one? It cancels out, right? So this just gives you 2NH3 aqueous, okay? Aqueous gives you your product is your silver amine complex AgNH32 plus 1 charge. What's the KEQ for this one? Is equal to the product of K1 and K2, right? KEQ for, what's KEQ for this first step? K1 is equal to 10 to the 3.24. Okay? And for the second step, K2 is equal to, we don't know. But what is K for the overall reaction? Kf is 10 to the, it's given, it's 10 to the 7.05. Okay? If you're given Kf, if you're given log of Kf, how do you solve for Kf? Here. Log of Kf for the overall reaction is 7.05. Therefore, Kf equals 10 to the 7.05. Okay? So Kf is 10 to the 7.05 is equal to K1, which is how much? 10 to the 3.24 times K2. So you can solve for K2. K2 would be equal to what? 10 to the 7.05 divided by 10 to the 3.24. So that's equal to 10 to the 7.05 minus 3.24. Remember, 10 to the x over 10 to the y is the same thing as 10 to the x minus y, right? So that gives us 7.05 minus 3.24, 3.81. 10 to the 3.81. And if you want an actual number for that, that's easy to see, to visualize. You take the 10 to the 3.81, take the analog, you get 6,456. Okay? So this has 2 decimal places. My answer should have, if I'm taking the antilog, your answer, the number of significant digits in your answer should be the same as the number of decimal places in the original number. So that would be 6.5 times 10 to the third. So that would be the equilibrium constant for the second step in the formation of the silver amine complex.